So good morning or good afternoon, depending on wherever you are in the world. I hope you're staying safe and well. Thanks for joining me today. My name is John Tinsley. I'm the CEO and co-founder of Iconic Translation Machines, and I'm very pleased to have the opportunity to speak with you all today on this webinar. We've actually had quite a lot of interest in this webinar series. We had more than 500 people actually register, so we had to upgrade our GoToWebinar account from the Pro to the Plus account to make sure we could accommodate everybody. So there's clearly an appetite for more information, maybe not only on this particular topic, but perhaps for alternative ways of sharing knowledge and discussions and more while our face-to-face interactions are curtailed, particularly in the form of conferences and trade shows and things like that. So this is the first in a three-part webinar series entitled Neural Machine Translation, the Past, the Present, and the Future. As the name suggests, we're going to take a look at the evolution of Neural MT from its relatively recent inception about 5 years ago through to the current state of the art. And then finally, everyone's favorite activity, looking into the crystal ball and taking a look at the trends and predicting where we're going to be in the coming years. Before we get started, a little bit of housekeeping. I'm going to keep this short and sharp. You're all busy people, so this whole webinar will be no more than 30 minutes. I'm going to speak for maybe 15, 20 minutes to leave a little bit of time for Q&A at the end. So if you have any questions, please make sure you pop them in the questions box in your GoTo tab. Should be on the right-hand side of your screen, and my colleagues will collect them and share them with me. If we don't get to your question, don't worry, we will make sure to follow up directly with you afterwards. We'll ultimately be making these webinars available online publicly, not till the end of the series, but you should get a follow-up email in the next day or so with a recording of this one too. So by way of brief introduction, in case you're not familiar, Iconic Translation Machines, or just Iconic, is a machine translation software and solutions provider. We're headquartered in Dublin, Ireland, where I'm speaking to you from today, more specifically my home office, where I've been camped now for about 70 days. We specialize in the development of bespoke neural machine translation solutions using proprietary technology adapted for a range of specific industry sectors like legal, life sciences, IT, and more. My own background is in computational linguistics. I hold a PhD in machine translation from Dublin City University, which I received back in 2009. And then subsequent to my studies, I worked as an applied researcher before ultimately co-founding Iconic with my colleague, Dr. Porg Sheridan, at the end of 2012. But that's enough about me. Let's look at the main topic here, which is neural machine translation. Or Neural MT, or NMT as it's also known. I'll probably use those terms interchangeably over the course of the webinars. But in this first webinar, we're going to take a look back to the beginnings of MT and the splash that Neural MT made when it came on the scene. So we're going to look at how the emerging technology hype cycle evolved with NMT, leading us to where we are today. I won't be getting into a lot of technical detail on this webinar. Some of that will come next week. So you might consider this one akin maybe to more of an MT history lesson, let's say. So when I said take a look back, I literally meant all the way back to when the original concept of machine translation was introduced. And you may be familiar with variations of this graph as well, and there is a copy of it also on our website. So MT kind of started, we've had, broadly speaking, three paradigms, as you see in the colors there. Everything started in the, I guess, early to mid 50s with what we know as rule-based machine translation, which emanated from Georgetown in collaboration with IBM. And basically they were working on Russian to English machine translation funded by the US government. So I'll give you any guess as to why they were interested in that particular language pair. And rule-based, as it suggests, the idea was you write sets of grammar rules to transfer between the two languages and then use dictionaries to fill in the words at the end. Let's just say it didn't work very well. There was a report actually published in the 60s called ALPAC, which basically said, this is a waste of time. It's not worth any more funding. And so everything kind of flatlined for quite a while. Probably until we hit the mid 80s, when there was a machine translation system called Meteo, developed in Canada to translate weather forecasts between French and English. And that actually worked really well because weather forecasts are quite a closed set. And there's only so many ways in which you can describe it. And so that kind of spurred a little bit of interest and then kind of research and development picked up. And then by the late 80s, early 90s, we had our first paradigm, or our second paradigm shift, our first shift, our second paradigm, to what was known as statistical MT. And what that was basically the application of statistics and kind of machine learning to the process of translation. And what it had done was it had taken methods that had worked well previously for things like speech recognition and applied them to the task of translation. And that was how MT was done until recently. For about 25 years. There were incremental improvements and evolutions on those models. So things went from word-to-word translation to phrase-to-phrase translation, and then adding in syntactic information. But really, I would say probably in the last 5-10 years of that, the improvements were quite incremental. And in order to get any sort of significant improvement, you did have to kind of really focus on something quite specific. And then in the mid 2010s, we had our next paradigm shift to neural machine translation, and that was kind of what caused a lot of waves. And then even then, within the first 3 years of neural MT, it internally went through a lot of evolution in terms of the type of neural MT, from recurrent neural networks to convolutional neural networks to transformers. Each one an improvement on the last, but the pace of improvement was what was so impressive, and how much it actually improved in such a short space of time. And this development was, and I guess still is, a subset of the broader AI revolution, as we know, has gained a lot of attention in the mainstream media, and with such attention comes the inevitable hype. And that's something that we all had to contend with for the first few years of neural MT's inception. The first such instance of this came following the publication of a paper by Google in late 2016. Now, this was a fairly standard form academic paper describing their new neural MT technology and some of the pretty impressive results they'd seen. But in the context of the news, let's not let the facts get in the way of a good story, as they say. So this is what you see here. That the title of this paper was "Bridging the Gap Between Human and Machine Translation." And in the paper, they had this conclusion, which you can see is quite qualified. So the emphasis is my own here, but it said, in some cases, human and Google translations are nearly indistinguishable on the relatively simplistic and isolated sentences sampled from Wikipedia and news articles for this experiment. So that's what they said. And this was how it was reported in TechCrunch, in Wired, and other BBC mainstream outlets. It's as good as a human translator, almost translates as well as human can. It's approaching human level accuracy. And this was the reaction of MT researchers and developers around the world. We'd seen this before. Was this another false dawn? The questions were going to start to be asked. And so we really kind of had to kick into expectation management mode. And this was just the first instance. There were subsequent instances of this, one notable one being Microsoft's claim of having achieved human parity with their NMT systems. That actually caused quite a lot of ripples in the academic community as well, which still linger to this day. We actually recently wrote a 2-part blog on that particular topic, which I'd encourage you to check out. I know some of the authors are actually on this webinar today as well, and we will touch on it a little bit in next week's webinar too. So, as I said, we very quickly moved along the hype cycle. So this is the Gartner hype cycle for emerging technologies. And by 2017, we'd reached what we call the peak of inflated expectations. That being said, there is no smoke without fire. The hype was justified to an extent. Neural MT brought with it significant performance improvements. And by that, we mean qualitatively and quantitatively better translations. It was measurable and it was impressive. And I'm going to show you one anecdote. I thought it's an appropriate anecdote given the era that we're in of Zoom calls and GoToWebinars and things like that. So one of the first neural MT engines we built was Russian to English. And this was the output produced for a particular sentence by our statistical engine. It said, "We checked, unfortunately, to organize video conference will not possible for technical reasons." Now, you know what they're trying to say there. We can't do a video conference for technical reasons, but that's pure machine translation. It's awkward, it's clunky, it's not quite grammatical, but maybe you can get a gist from it. When we built the neural system, this was the translation that we got. Unfortunately, we've clarified that it will not be possible to organize a video conference for technical reasons. So as you can see there, that's kind of the idea, an idea of what it can give you. It's a much more fluent, much more usable translation. And while that is an anecdote, as I said, it is kind of emblematic of the type of improvements that can be achieved with Neural MT. So the question is, why is it better? And without getting into the weeds, it's using data essentially to learn how to translate in a different way. So similar to the way statistical MT was using approaches applied to speech, Neural MT was using techniques that were very successfully applied to tasks such as image recognition, which you'll have noticed got a lot better online in the last years. So it's looking at more context as well. So it's looking at the whole sentence rather than word by word or phrase by phrase. So it's more akin to how a human would translate, hence the neural aspect. And consequently, the translations are simply better. So like I said, this ongoing improvement kind of continued at pace. I mentioned earlier that we already saw evolution in the types of neural networks used and the features that were being added to them, such as attention mechanisms, the speed of how we train new models, and that process becoming more efficient. But one notable difference here with Neural MT was that the research wasn't just emanating, let's say, from the typical academic institutions known for their work on MT. Big tech companies were also at the forefront here, with the likes of Amazon, Facebook, and Baidu getting involved, publishing their work on the topic, in addition to the aforementioned work from the likes of Google and Microsoft. And of course, there were other commercial entities such as ourselves at Iconic. We're pretty active in developing on this new paradigm as well. However, there was still the need to manage the expectations somewhat, because like I said, while the quality had massively improved on the whole, in the early days, there were still quite a number of practical considerations before we could consider Neural MT ready for prime time or for production. And these issues, considerations included such things like, the time and cost required to actually build engines at scale, the amount of data that would be required to do so, arguably more than before, and the inability to do key things that were pretty standard with statistical MT, such as using client terminology, handling tags during translation. And lastly, probably most importantly, the fact that the engines behaved in quite an unpredictable way at times, and they were a little bit less robust. So you get kind of random translations, repeated words in the translations, and sometimes missing translations that we couldn't easily explain. And so these were conversations that we had to kind of have extensively with clients, outwardly facing, while in the background, working as hard as we could to try and overcome these issues to find answers so that we could actually deliver the positive sides of Neural MT in production as quickly as possible. And another factor that was really driving the development of statistical MT at the time was the availability of open source tools. And while there were a number of different options from an open source perspective in the 2000s, ultimately Moses emerged as the go-to tool for building MT engines. You're probably all familiar with it. It was EU-funded open source tool originating from the University of Edinburgh and principally maintained there over a number of years. But it wasn't only used for research, it was used a lot in production. And in fact, a lot of commercial organizations who are offering MT as a service were probably just using Moses off the shelf in the background in order to deliver this. And at the beginning, there was no such similar option for a Neural MT, but that quickly changed, I would say. So firstly, there were a release of a number of tools born out of academia, such as Theano, which came from NYU. We had Nemetus, which is now, I think, in Edinburgh as well. We had Amu NMT, which later became known as Marion. And then there was OpenMT, which was a little bit of an academic industry collaboration. And then we had a subsequent wave of open source tools released by industry players, which was a first from an MT perspective. So we had the likes of Sockeye from Amazon, Fairseq from Facebook, and Google's TensorFlow platform. And these served to, I guess, somewhat democratize the training of Neural MT engines and accelerate the rate of research and development. But while this did allow people to get their hands dirty with NMT, the rules of engagement had also changed quite a bit. It was no longer really a case of taking whatever data or translation memories you had, dropping them in and clicking train and getting an empty engine at the other end. Firstly, there were and still are a number of ways in which to configure Neural MT models for training in terms of the number of layers you use, the epochs, and particularly the strategy for optimizing the engines given the data you have towards a particular goal. And secondly, it was quite quickly established that neural MT was a lot more susceptible to noise in the training data, and it was definitely not as robust when it came to trying to translate things that it hadn't seen before. And the result of this was those unpredictable and sometimes inexplicable translations that I referred to earlier, essentially translations that on the surface had absolutely nothing to do with what you were seeing on the source, which is not great in a practical scenario where you have to maybe explain to a customer or get them a level of comfort with the technology. So in some ways, because of that, not to be too cliche, but data had become the new oil, the new kind of resource here that everybody wanted, but then also the expertise and the skill to actually be able to understand the nuances behind what was going on in these models, and then manipulate the data in a particular way in order to extract the best results from a neural MT engine for a particular domain, for a particular client, or a particular use case. That's what has become increasingly crucial today. And that's why the kind of click and train neural MT solutions, like some of the ones you can find online, can often be significantly improved upon by domain specific or client specific engines that have an extra level of customization and adaptation done to them. But as a consequence of this, as it stands today, no single one of those tools that I mentioned on the previous slide are the go-to standard for neural MT in the same way as Moses was. Actually, the choice of tool will often depend, let's say, on the strength and weaknesses of the specific implementation of the underlying deep learning toolkit, whether it's PyTorch or something else. And then I think the fluency of the developer, whoever's actually building the MT engines, their fluency in a particular programming language, such as C++ or Python, will have an impact on what tools ultimately get used. And we've seen that a lot of these different tools are used by different commercial providers and in different research groups around the world. But as the slide suggests here, what we can say for certain is neural MT is now definitively state of the art in machine translation. At the outset, there were things like hybrid systems, which maybe had some failover options. Let's say the neural MT didn't produce something well, it would fall over to something from an SMT perspective. But now neural MT has essentially fully replaced most other paradigms, or the rule-based and statistical paradigms. There may still be some legacy SMT engines in the wild. I think we still even have one or two that some clients are hanging on to, but we definitively now have a new king of the mountain when it comes to machine translation. Therefore, we have it easy. We can kick back and relax because the machine translation problem is solved and our work here is done. Excuse the picture. I've been rewatching a lot of the UK office while in lockdown. But no, obviously not even close. We're not even near to being finished. There are still a lot of open questions, such as, for example, what do we do for languages or use cases where we don't have a lot of data? How do we effectively handle specific terminology or perhaps translate unseen words that aren't in the training data that we have? How can we tell exactly which words are translated as which? So this is alignment information, because this is something that we would use to put tags back in. This word translated as this, I need to put a tag after this. Can we incorporate monolingual information in there to validate the output? So language models were a key part of statistical MT, and there's something that is only beginning to be kind of reintroduced in neural MT. Domain adaptation, how do we make the engines more flexible for different types of content? Because as I mentioned, they're more susceptible to noise and they're not as good as translating things they haven't seen before. So how do we make sure we kind of adapt it? And then lastly, as I alluded to earlier on with the topic of human parity, how do we go about properly evaluating neural MT output? These are some of the questions that are facing researchers and developers today, and there is a lot of time and effort being spent on addressing them, not only in research scenarios, but also commercially speaking too. However, you are going to have to come back next week for a deeper dive on what those topics are. Just to point out what you see on the slide there, over the past 2 years at Iconic, we've been writing a blog on our website called the Neural MT Weekly, in which members of our scientific team at Iconic, including guest posters, some of whom again are on the webinar today, pick, let's say, a recently published paper on a specific topic in Neural MT and write a summary of its finding and its practical relevance. So as of today, we've published 82 articles. I think 83rd is going up later on today. And there are certain trends and topics that keep resurfacing. And these are the key areas where neural MT researchers and developers are focusing a lot of their efforts. So in next week's webinar at the present, what we're going to do is pull out and summarize a range of those key issues, most of which, or a lot of which I mentioned on the last slide. We're going to discuss what they are, why they're particularly important, and what the technical challenge actually is. Why is this hard? Why haven't they been solved yet? In the meantime, I'd encourage you to check out the blog yourself. The link is there on screen, iconictranslation.com/knowledge/the Neural MT Weekly. But for now, I'm going to stop there. Thank you for your attention. As I said, next week, I'll be covering some more of the forward-looking aspects. But now I'm happy to answer a few questions on some of what I've just covered. So if you give us a minute or two, we're going to collect some of the questions that have come in and maybe address them. Thank you. So there's one question has come in. I guess it's more of a point as opposed to a question, but it's a fair point. Pointing out that actually the concept around MT started in the 1920s, which was, I guess, when the concept came around, but there was no practical implementation. And then so there was Warren Weaver's memorandum on MT, I think in 1944, 49, which was, I guess, the precursor then to those IBM models that were developed in collaboration with Georgetown. So that was kind of the genesis of the idea, and then that Georgetown IBM implementation that I mentioned being the first practical implementation. There's another question here, which is the challenge of picking live questions. I'm not sure how I'm going to answer it, but I'll give it a go. It says, how much better is neural MT over statistical MT than statistical MT was over rule-based MT? Interesting. So I wasn't around when statistical MT, I wasn't reading research papers when statistical MT came in. It's hard to say. I would say there probably wasn't as big a splash, let's say, as there was when we saw early neural MT engines come in, and literally just reading translations and looking at them going, wow, that is just way better than anything we had before. I think with statistical MT, a lot of it was dependent on the data, but when I think the splash statistical MT made was more around the concept, I would say, and less around the immediate results that we saw, because actually we had some really good quality rule-based systems, to the extent that up until, I would say, maybe 5 years ago, there were still companies who had rule-based systems in place because they had been so highly curated over such a long time that the grammars were so well written and the dictionaries had such good coverage that they were still producing good translation. So it wasn't the case, let's say, that SMT ever completely usurped RBMT in all cases, but definitely I think neural MT kind of made a much bigger initial splash with the results that we saw at the outset. So there's actually quite a lot of questions coming in, so we're definitely not going to get to it all. I'm going to have a quick look. It's an interesting question that says, is it true that investment in neural MT has declined because it has reached a plateau quality cost-wise? It's a good question. I guess it depends on whether you mean has declined in terms of how investment in neural MT was at the beginning or compared to statistical MT. I would say I don't necessarily think so. Maybe the nature, and I guess there's investment and there's funding. So a lot of research in machine translation is funded by, let's say, the European Commission or similar state bodies around the world. And with SMT, they had funded a lot of, I guess, more fundamental research. And maybe there's a little less of that kind of funding for pure research, for research sake, let's say. A lot of the funding, so Iconic is involved in 2 Horizon 2020 projects, and the funding there is involves neural MT engine development, but it's very practically driven. It's use case driven. There are users involved in the projects, and so maybe I would say the investment or the funding hasn't stopped, but it's been refocused into kind of making the outputs a little bit more practical from a usage perspective. I'm going to see if we can squeeze in one more question. So there is a question, it's the last question, which I'll use as a teaser for next week. The question asks, is it fair to say Neural can focus on complete sentences, which allows the identification of different structures? Is there anything focused on paragraph level, or is that not even necessary? We'll get into that next week. Document level context, or context beyond just the sentence level, is something you're going to see a lot more of in the coming future. We're giving too much away. That's definitely going to be in webinar 3, for sure, talking a little bit about that. One last question. We've got 2 minutes left before the half hour. Somebody has asked, why are there still companies using statistical MT engines commercially? I mean, I can't speak for other companies. We have 2 statistical MT engines still in production, and there's a specific reason for each one. With one client, they don't want to change. It's in their contract that we can only change something that fundamentally if with their permission, and they don't want to change it. They're kind of happy with the infrastructure that they have, and so be it. With the other client, it's a question of kind of what I alluded to a little bit there with RBMT. They're thinking it in a case of, if it's not broken, don't fix it. So they have an SMT engine that's working very, very well for their particular purpose. Yes, we could improve upon it with NMT, but for this particular use case that they have, it's doing the job, and the job couldn't be done any better. The MT is completely fit for purpose. So just looking at it logically, like, why would you even change? So that's why maybe there are other reasons that other companies have. Expertise is going to be a big one, because where there was expertise around SMT, that doesn't necessarily transfer like for neural MT. So the reasons could be many there. So I'm going to wrap up there. There are a lot more questions in, but like I said, if we haven't answered the question that you've asked, we will follow up with you in a short email, and keep an eye on your inbox, where you will get a recording of this webinar in the coming days. So that's all. Thank you for now, and hopefully I will see you all again next week too. Thanks very much. Bye-bye.